So circular functions is just a function defined by a circle, by a circle. Example, the unit circle, okay? And when we graph circular functions, then typically, what did you find went on the x-axis? On your big pieces of graph paper, what units went on the x-axis? The degrees, yeah. So a circular function, what we're noticing, is going to produce a cycle, and typically the degrees are graphed on, the degrees become the x-axis, okay? So you're taking something that looks like this and we're graphing it onto something that looks like this. And so we learned when the unit circle, we'll do some more really specific graphs on Tuesday, but the sine curve started here and like did this, okay? And do you guys remember where the cosine curve started? It was one spaghetti, right? Okay, so the cosine just came and started here and then ended at its top. All right, so something like that. That's not a great graph, but all right. Something about circular functions is if I go around the circle and I get to 360, couldn't I go around the circle again? Yeah, we talked about that. That's called coterminal angles, right? And couldn't I keep doing that forever? So what do you think's going to happen to this wave if I did another round about the 360 around the circle? Is it would continue, right? Is there such a thing as negative angles? Can you just give me a nod? Is there such a thing as negative angles? Yes, we've talked about that. That's just going this way, right? So guess what? Your curves could also go this way forever. Okay, I think there was a question on your questions sheet about if the graph would continue on. Yeah, it would. Both graphs would continue on because you can go forever around the circle and that pattern would repeat. Okay, so as far as unit circle questions go, and then we're going to leave unit circle and just talk about all periodic functions. The terminal side of an angle theta in standard position intersects the unit circle at the point 1/2 root 3 over 2. And we can actually use our unit circle if we want, but we don't really need to. If I'm telling you it intersects the unit circle at that point, and I say, what's the cosine? You're going to tell me the x-coordinate. So what's the cosine at that angle? It's literally the 1/2 there. So the cosine at that angle is 1/2, and the sine at that angle equals root 3 over 2. All right, so points on the unit circle, the x-coordinate represents the cosine, and the y-coordinate represents the sine. Okay. The sine and cosine, when we graph them on an x-axis, I also hinted at this in our activity, are called periodic functions, okay? So let's talk about what a periodic function is, and then I have some pictures of things that are periodic and some things that are not. A periodic function has a y value that repeats at a regular interval, okay? Now, that doesn't mean a pattern that repeats. It specifically has to look exactly the same along the x-axis, okay? One complete pattern is a cycle, and the horizontal length of one cycle is called the period. Okay. So when I say a cycle, I mean a cycle is just telling me the sine wave started, it went up, it comes back to the beginning. That's one cycle, okay? So if I'm looking here, this is a sine curve. It starts here, it comes up, it goes down, and then do you see that's where the pattern would begin again, where it would go up? Are you seeing that? Okay. What I highlighted in yellow is called one cycle of the curve. If I did another one, that would be a second cycle. If I did another one, that would be a third cycle. Does that make sense? the amount of time that it takes to get that whole cycle down here, the length of time on the x-axis, and I know it's done in radians, we're going to really worry about degrees, but I hope this makes sense to you. This length of time is called the period. It's like, think of it as the period of time. You probably have heard that phrase before, to do one cycle, okay? This sine and cosine both had a period of 360. That was question number 1. That's why 2 pi is 360, okay? But what we're going to do today is we're going to take a look at some other things and decide what do we think their period is. Okay, so first of all, let's take a look at something non-example. Do you understand why this is not periodic? I mean, there's a nice little pattern going on there, but in order for it to be periodic, what would have to happen is after this, it would have to do the exact same thing again. So let's say, I don't draw this, I'm going to just draw it. Let's say it did this again, and then followed by that, and then followed by the next thing, then it would be periodic if it went and repeated those exact same y values. Okay, do you see this guy? Hopefully you can tell that this is periodic. That's one cycle of it, okay? That's one cycle, that's when the pattern repeats. So if I asked, what's the period? How long did this take? Could we all agree that the period of this would be 4? It takes 4 units for one cycle. Give me an indicator, guys. I know you're tired, but I just want to know you're out there and that's sinking in. Okay. Let's flip onto the back. And then I'm going to talk about a little bit more vocabulary with these things. So next, I say determine the period of the function. Okay, so let's figure out, if you have a highlighter, maybe just trace one cycle. So it does this triangle thing, and then it does a semicircle, and then do you see it starts the same pattern again? So what I just highlighted is one cycle. Okay. So then I'm going to talk about, let's determine the period. In other words, remember the period is how long on the x-axis does it take to complete that. Would you turn and talk to somebody around you about what you think the period is of this? Okay, I'm hearing that people are saying 10. Good, you're getting this. The period of this graph is equal to 10. Okay, let's talk about 2 more terms that you're going to hear over the course of next week. So I'm going to just have you write those terms down here. There is something that is called an amplitude, okay? The amplitude is the height from the middle to the top of the graph. Okay. So typically, there's like some symmetry going on here, and I think it's the same thing here. The middle of this graph is that x-axis. Are we seeing that? So the amplitude would just be, hey, how tall is this right here? How tall is that piece? And it looks to me, I don't know, this one's not a perfect scale, but it looks like it's a little less than 1. Agreed? Okay. All right, so we'll talk about that on this one as well. Then there's also something called the midline. What do you think the midline is? Just think about what that word means. Right down the middle this way. Yeah, so the midline, like on this one, would be, it looks like going right down the middle of the curve, splitting the top and the bottom in half. The midline just cuts the curve in half. So if you hear those phrases, that's what I'm referring to. Okay, I didn't put that on our note guide, but you might hear them. All right, next example. Ooh, this one's a little tougher, I think, because it doesn't give you a graph, like of the whole. I would like to see a little more. Okay, let's highlight what you think one cycle is. Some of you are going to get this wrong. Highlight what you think one cycle is. Does the square thing. 2 triangles. I'm going to stop right there. Then it's doing the square thing. It does. What should happen next, by the way, if I said, hey, continue this graph? The pattern is this flat and then 2 triangles. So then I go flat and I have 1 triangle. What's going to happen? Another triangle. Okay, good. So you're seeing, if I'm telling you it's periodic, that's not a perfect triangle, but we get the idea. So this is one cycle. Okay, it's in terms of pi, guys. Okay, it's in terms of pi. So this is 1 pi, this is 2 pi. To get back down to the bottom, it's halfway between 2 and 3. What would you call that? 2.5 pi. And like I said, mostly for us, I'm going to do things in degree mode, but some things you're going to see today are in radians as well. Okay, last thing about periodic functions. The unit circle is periodic, and I asked some questions about this. Well, kind of. You asked me the question about the 150 and the 30, right? And then we talked about how there are more than one value on the unit circle that have the same sign, okay? Who remembers the question about, there's a question about 390. Do you remember that question? Okay. Hopefully you answered it correctly. If not, I'll let you go change it. So if I went around the circle, 1 full rotation is 360, agreed? So wouldn't 390 be the same thing as 30? So then we could use the unit circle again and figure it out. So that's using the fact that it's a periodic function. 390 isn't on here, but you guys knew after 360 degrees, that's the period. It repeats again. So we're going to use that idea. We're going to use that idea to find these values on our unit circle, and I'm not going to have you memorize it. We're just going to take this out, okay? So let's deal with sine of -60. All right, on our unit circle, where would -60 be? Can you just talk to somebody around you? Just point to the degree that you think -60 would be. Maybe compare with somebody. So -60 is the same as the point 300. Think about that, right? 360 minus 60, 300. Okay, and the question I asked, so we're looking at this point right down here. I asked for the sign. Remember, the sign is the second or the y coordinate. So we would just write -√3/2 for that. All right, let's go to the next one. Cosine of 405. Okay, well, 405 is above 360, right? Let's get our calculators out. Maybe you don't need a calculator. What is 360 or 405 minus 360? Because this is going to be the same thing. What is 405 minus 360? What do we get for that? $45. Okay, so now that just means that that is the same spot on the unit circle. So we're going to go and look at 45. So 45 is right here. And we are going to write the cosine. Lucky for us, the cosine and the sine are the same here. So, but the cosine is the x-coordinate, so the answer to that one would be √2/2. And on this section, we are not using our calculators. We are using the unit circle for our cosine and sine, okay? Sine of 540. Okay, would you subtract 360 from 540? And what do we get? 180. Okay, so this is the same thing as finding the sine of 180 degrees. So 180, I go all the way across right here. The sine is the y coordinate, so I would write down 0 for that. Okay. So that's all there is to our unit today. Let's see here. I'm going to do a couple on a whiteboard just to make sure you got it.